The Agile Duo, mastering pair programming and extreme programming. 1. Beyond solitary coders, the case for extreme collaboration. For decades, the image of the software developer remained stubbornly fixed in the popular imagination. A solitary genius, often hunched over a glowing screen, fueled by caffeine and an almost mystical ability to conjure complex systems out of thin air. This romanticized view, while appealing to the narrative of individual brilliance, largely obscured the true nature of creating sophisticated software in the modern age. It suggested that groundbreaking digital products were born from singular acts of creation, much like a lone architect might design a magnificent skyscraper from scratch. Yet, this analogy quickly falters. While a single architect might conceive the grand vision, the actual construction of a towering building requires hundreds, if not thousands, of highly coordinated individuals. Engineers, builders, electricians, plumbers, laborers. Each plays a crucial role, collaborating intensely to bring the design to life, meticulously ensuring each component fits perfectly within the grand scheme. Modern software development is no different. From tiny mobile applications to vast enterprise systems, contemporary software projects are almost never the result of a single individual's effort. They are, at their heart, complex team endeavors. The accelerating pace of technological change has only amplified this reality. Today's businesses demand software that is not just functional, but also delivered faster, with higher quality, and with an inherent ability to adapt rapidly to ever-shifting market conditions and user needs. The traditional, sequential approaches to software development, often referred to as waterfall, due to their cascading phases of requirements gathering, design, coding, testing, and deployment, proved too slow and inflexible. Projects became bogged down, exceeding budgets, missing deadlines, and too frequently, delivering software that was already obsolete or irrelevant by the time it reached its users. The question became urgent. How could teams consistently build high-quality software quickly, respond elegantly to constant change, and ensure continuous product relevance in a dynamic world? The answer, for many, began to emerge in the form of Agile methodologies. Agile is not a single, prescriptive method, but rather an umbrella term for a set of values and principles outlined in the Agile Manifesto of 2001. These principles emphasize flexibility, collaboration, iterative development, and continuous feedback, positioning human interaction and working software above rigid plans and documentation. Agile was a direct response to the limitations of traditional, heavyweight methodologies and quickly gained traction. Among these emerging Agile approaches, one stood out for its bold, even provocative, name: Extreme Programming, or XP. Coined by Kent Beck, one of the original signatories of the Agile Manifesto, XP wasn't designed to be radical or reckless. Instead, it took commonly accepted good practices in software development, like meticulous testing, simple design, frequent communication, and human collaboration, and pushed them to what was then considered extreme levels. For instance, if regular testing was a good practice, then continuous automated testing before writing code, test-driven development, was XP's extreme take. If code review was beneficial, then constant, real-time code review as an integral part of development, pair programming, became a cornerstone practice. At the very heart of extreme programming lies a practice that is simultaneously simple in concept and profound in its implications. Pair programming. Forget the image of a solitary coder. Picture two developers seated side by side at a single workstation, collaborating on the same code simultaneously. One acts as the driver, actively typing and focusing on the immediate task. The other, the navigator, continuously reviews the code, suggests improvements, anticipates problems, and considers the broader architectural implications. This isn't just about sharing a keyboard. It's about shared problem-solving, real-time knowledge transfer, continuous quality assurance, and fostering deep team understanding. The promise of this intense, extreme collaboration is compelling. The ability to deliver high-quality software rapidly, to foster deep shared knowledge within a team, to achieve better code design, and to build resilient teams capable of embracing constant change. It's about optimizing human interaction and communication to solve complex problems in ways that individual effort rarely can. This book, The Agile Duo, Mastering Pair Programming and Extreme Programming, aims to demystify these powerful, yet sometimes misunderstood, Agile practices. We will delve into their history, values, and principles, exploring not just what they are, but crucially, why they work. We'll provide practical guidance on how to implement them, discuss common myths and misconceptions, explore real-world success stories, and address the challenges teams often face when adopting these methods. Ultimately, you will gain a clear understanding of how these seemingly extreme practices can contribute to building better software, fostering stronger teams, and navigating the ever-evolving landscape of modern technology. 2. Roots of Agility, where extreme programming began. To truly understand extreme programming, or XP, we must first journey back to the late 20th century, a period often referred to as the software crisis. By the 1990s, the software industry was grappling with a harsh reality. An alarmingly high percentage of large-scale software projects were failing. They routinely exceeded their budgets, missed their deadlines, or, perhaps most painfully, delivered systems that simply failed to meet the evolving needs of their users. The traditional waterfall approach, a sequential, linear process moving from exhaustive requirements gathering to design, coding, testing, and finally deployment, was increasingly seen as the culprit. Its rigid structure struggled to cope with changing requirements, and its long feedback loops meant that problems often weren't discovered until it was immensely expensive, if not impossible, to fix them. Imagine designing a complex building on paper for 2 years, only to begin construction and realize the foundation is flawed, or that the landscape has shifted dramatically, requiring a complete redesign. This was the predicament of many software projects. The starkness of this crisis was highlighted by reports like the 1994 Chaos Report from the Standish Group, which found that a significant portion of IT projects were either outright failures, canceled before completion, or serious challenges, completed but over budget, behind schedule, and with reduced functionality. This grim landscape spurred a collective push among forward-thinking developers and managers to find better ways of building software. From various corners of the globe, different groups began experimenting with more adaptive, iterative, and flexible ways of working. These approaches were often dubbed lightweight methodologies, in contrast to the ponderous, document-heavy processes prevalent at the time. Names like Scrum, Dynamic Systems Development Method, DSDM, and Crystal emerged, each with its unique flavor, but all sharing a common conviction: there had to be a better way. They began to prioritize people and interactions over rigid processes and tools, and working software over exhaustive documentation. Within this ferment of innovation, extreme programming took shape. Its primary architect was Kent Beck, a renowned software engineer and influential thinker, working with collaborators like Ward Cunningham and Ron Jeffries. XP truly began to formalize on the Chrysler Comprehensive Compensation C3 payroll system project at Daimler Chrysler, starting in 1996. Facing a complex, high-stakes project that seemed destined for the typical software crisis pitfalls, Beck introduced a radical new way of working to the team. The name, Extreme, wasn't chosen lightly. Beck's philosophy was elegantly simple. If a practice was good, the team should do it more. If testing software was good, then they should be testing all the time, even before writing the code, test-driven development. If code reviews improved quality, then they should conduct them continuously, in real-time pair programming. If design was crucial, then they should design simply and evolve the design continuously through refinement, simple design, and refactoring. XP codified and pushed these beneficial practices to a disciplined, consistent level, amplifying their positive effects. This evolving landscape of lightweight methodologies culminated in a pivotal moment for the software industry. In February 2001, 17 independent and often iconoclastic software developers, leaders and innovators behind methodologies like XP, Scrum, and FDD, gathered at a ski resort in Snowbird, Utah. Their goal was to find common ground, to articulate the values and principles that underpinned their various approaches to software development. The outcome of this gathering was the now famous Manifesto for Agile Software Development, more commonly known as the Agile Manifesto. The Agile Manifesto laid out 4 core values that would become the philosophical bedrock for an entire movement: individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. It didn't dismiss processes, tools, documentation, or plans entirely, but rather articulated a preference, an emphasis on what truly creates value and adaptiveness in software development. Extreme programming is perhaps the most explicit embodiment of these Agile Manifesto ideals. Its deep emphasis on face-to-face communication, through practices like pair programming and having an on-site customer, directly reflects the prioritizing of individuals and interactions. XP's relentless focus on delivering working software through small, frequent releases and continuous integration underlines the second value. Its planning game and empowered on-site customer foster direct, daily customer collaboration. And perhaps most profoundly, XP's practices of test-driven development, refactoring, and small releases are designed to enable teams to respond to change gracefully and efficiently, rather than rigidly adhering to an outdated plan. At its heart, the spirit of XP is one of continuous adaptation and improvement. It demands incredible levels of communication, where team members talk constantly and share ideas freely. It requires a commitment to simplicity, always striving for the leanest, most effective solution. It thrives on rapid feedback, from automated tests that confirm correctness to frequent demonstrations to customers that validate direction. Most critically, it calls for immense courage: the courage to change designs when necessary, to delete code that no longer serves a purpose, to openly admit mistakes, and to embrace the unknown. This disciplined yet flexible approach, born from the challenges of the past, set the stage for a revolution in how software is built. 3. The XP Blueprint: values, principles, and practices. Extreme programming isn't merely a collection of isolated techniques. It's a coherent system built upon a foundation of core values and guiding principles. These fundamental beliefs shape the environment, attitudes, and ultimately, the practical activities, the practices that define XP. Understanding this blueprint is essential, as the practices derive their power and meaning from the values and principles they uphold. The 5 core XP values. Kent Beck, XP's progenitor, identified 5 interconnected values that underpin the entire methodology. These aren't just feel-good sentiments. They are actionable ideals that inform every decision and interaction within an XP team. Communication. In software development, misunderstandings are a constant threat. Misinterpretations of requirements, unspoken assumptions about design, or unshared knowledge about complex systems can lead to defects, rework, and project delays. XP combats this by prioritizing active, immediate, and face-to-face communication over extensive, often outdated, documentation. In practice, pair programming forces constant dialogue between developers. The on-site customer feature ensures there's a living, breathing source for requirements clarification right with the team. Daily stand-up meetings keep everyone aligned. The idea is to talk through problems and solutions, ensuring shared understanding in real time. Simplicity. The XP approach to design is deceptively simple. Do the simplest thing that could possibly work. This doesn't mean designing poorly or skipping necessary steps. It means building only what's needed for the current iteration, no more, no less. Complex designs are harder to understand, test, and change. XP advocates for incremental growth, evolving the design only when new requirements demand it. In practice, this value leads to the "you aren't gonna need it" YAGNI principle, avoiding speculative features or over-engineered solutions. It also underpins the practice of simple design, where code is kept as clean and straightforward as possible, making it easier to maintain and adapt. Feedback. Quick and frequent feedback is the lifeblood of XP. It allows teams to correct course rapidly, learn from mistakes, and validate their assumptions. Feedback occurs at multiple levels: from the code itself, from team members, and from the customer. In practice, test-driven development (TDD) provides immediate, automated feedback on code correctness. Continuous integration, CI, alerts the team instantly if newly added code breaks existing functionality. Small, frequent releases provide valuable feedback from actual users, allowing the team to adjust priorities and plans based on real-world usage. Pair programming also provides constant human feedback. Courage. This value is perhaps the most nuanced. It's the courage to change design and code when needed, even if it means refactoring a large section of working code that someone invested heavily in. It's the courage to admit when a design isn't working and to scrap it. It's also the courage to communicate openly, to accept and act on feedback, and to make realistic commitments. In practice, the practice of refactoring requires courage to continually improve the code's internal structure. It also requires the courage to deliver small pieces of software frequently, trusting that fast feedback will catch any missteps. Respect, trust, and respect are foundational for any highly collaborative environment. XP emphasizes respect for all team members, individual contributions, and the project itself. It means trusting one another's competence and assuming everyone is doing their best. In practice, this value is crucial for effective pair programming, where partners must listen to and value each other's perspectives. It also underpins collective code ownership, where every team member is empowered to improve any part of the codebase, trusting that their colleagues will respect their changes and efforts. The underlying principles of XP. Beyond these 5 values, XP is also guided by a set of principles that provide philosophical depth and reinforce the values. While less frequently elaborated than the values or practices, they offer a deeper why for XP's approach. Humanity. Acknowledging that software is built by fallible humans for other humans, emphasizing human well-being and capability. Economics. Focusing on delivering the most value for the money spent and understanding the cost of change. Mutual benefit. Designing practices that create positive outcomes for all involved developers, customers, and business alike. Self-similarity. Recognizing that effective patterns at one scale often apply at others. Improvement. A commitment to continuous learning and adaptation for individuals and the team. Diversity. Valuing different perspectives and skills within the team. Reflection. Regularly taking time to examine what is happening and how to improve. Flow. Striving for a steady, sustainable pace of work. Opportunity. Viewing problems or changes as chances for improvement. Redundancy. Building in safeguards through practices like automated tests. Failure. Learning from mistakes and seeing them as opportunities for growth. Quality. Never compromising on the inherent quality of the software. Baby steps. Making small, incremental changes to achieve larger goals. Accepted responsibility. Teams, not individuals, take ownership of their work and commitments. Introduction to XP practices. The practices are the tangible activities that XP teams undertake daily. They are the how-to of XP, directly embodying the values and principles. While each practice can stand on its own as a valuable technique, their true power in XP comes from their synergy. How they interlock and reinforce each other to create a cohesive, adaptive development system. We can broadly group these practices for clarity, though in reality they weave together seamlessly. Practices for planning and management. The planning game, collaborative planning between the customer and the team. Small releases. Delivering working software in very short cycles. On-site customer, embedding a customer representative directly with the development team. Practices for coding and design. Pair programming, 2 developers working at one computer. Test-driven development, TDD, writing tests before writing production code. Refactoring, continuously improving the internal design of the code. Simple design, building only what's necessary, nothing more, nothing less. Collective code ownership, the entire team owns all the code. Coding standards, agreed upon rules for code style and structure. Practices for feedback and quality assurance, continuous integration, CI. Integrating code changes frequently, with automated tests. TDD, small releases, and on-site customer also heavily contribute to feedback. Consider how they interlock. Pair programming fosters communication and shared understanding, which helps in applying simple design. Simple design makes refactoring easier, and refactoring is made safe by the comprehensive safety net of tests created through test-driven development. TDD and refactoring ensure high quality, which then allows for the confidence needed for continuous integration. Small releases leverage the clean, well-tested code to provide rapid customer feedback, guided by the on-site customer, feeding back into the planning game. It's a holistic ecosystem designed for continuous improvement and adaptability. On a typical XP team, a day in the life is highly collaborative. Programmers arrive, quickly pair up, discuss the next user story, a small piece of functionality with their pair, and possibly the on-site customer. They then proceed to write a failing test, write code to make the test pass, and then refactor it for cleanliness, all while constantly talking to their pair. As they complete small tasks, they frequently integrate their changes, confident in the automated build and test process. Progress is measured by working software, not just written code, ensuring that the team always delivers value. This vibrant, feedback-driven cycle is the engine of extreme programming. For the heart of XP, mastering pair programming. If extreme programming were a living organism, pair programming would undeniably be its beating heart. It is the practice most identified with XP, often sparking both fervent advocacy and skeptical glances. While appearing deceptively simple to people, one computer, its benefits ripple outwards, positively impacting nearly every other aspect of the development process. What is pair programming? Driver and navigator roles. At its core, pair programming involves two developers working together at a single workstation on the same piece of code. They share a keyboard, mouse, and screen, and they continually discuss the task at hand. Within this arrangement, two distinct yet fluid roles emerge. The driver. This is the person actively typing code, focusing on the immediate implementation details, syntax, and putting the current thought into the computer. The navigator. This person observes the driver's actions, thinks at a slightly higher level, reviewing the code as it's written, considering the overall design, anticipating future steps, identifying potential problems, and suggesting alternative approaches. The magic happens when these roles switch frequently, typically every 15 to 30 minutes, or after completing a small subtask. This ensures both members actively participate in both roles, preventing one from becoming passive and keeping both engaged. It's not about two people doing the work of one. It's about two minds solving a problem as one, with continuous, real-time quality assurance. To draw an analogy, think of a pilot and co-pilot in an aircraft. One, the pilot, is actively manipulating the controls, focused on the immediate task of flying. The other, the co-pilot, monitors instruments, reviews checklists, manages communications, and looks ahead, ensuring the flight plan is maintained and anticipating potential issues. They constantly communicate and can swap roles seamlessly. The why benefits beyond just sharing a keyboard. The immediate perception of pair programming often leads to the question, wouldn't that have productivity? While it might seem counterintuitive to have two people working on what appears to be a single task, the benefits often outweigh the perceived costs, especially in the long run. The value of pair programming extends far beyond simply getting code written. Continuous code review. This is perhaps the most immediate and tangible benefit. With two sets of eyes on the code, defects are caught earlier, often as they are typed. This immediate feedback loop means fewer bugs slip into the codebase, reducing the time and cost associated with later debugging and rework. Two heads are better than one is not just a cliché. It's a verifiable truth in preventing errors. Knowledge transfer and shared ownership. Pair programming is a remarkably efficient way to disseminate knowledge across a team. Less experienced developers learn best practices, coding conventions, and system architecture directly from their more experienced partners. Senior developers, in turn, deepen their understanding of different parts of the system and gain fresh perspectives. This constant knowledge sharing reduces the bus factor, the risk associated with critical knowledge residing with only one individual. When knowledge is shared, the team collectively owns the code, reducing dependencies and fostering resilience. Improved code quality and design. Collaborative problem-solving often leads to more robust, cleaner, and better designed code. pairs are less likely to yield to the temptation of taking quick, dirty shortcuts. The constant dialogue and debate force deeper consideration of design choices, leading to more elegant and maintainable solutions. Accelerated learning. New team members or those unfamiliar with a particular part of the system can ramp up much faster through pairing. Learning happens organically through direct interaction, immediate context, and active problem solving, rather than through isolated documentation or separate training sessions. Increased communication and team cohesion. Pair programming inherently demands clear, articulate communication. Developers are forced to verbalize their thought processes, which clarifies understanding not just for their partner, but often for themselves. This continuous verbal exchange builds stronger team bonds, fostering trust and a shared sense of purpose. Reduced defects. Studies, while varied, often show that pair-programmed code has significantly fewer defects than individually written code. The quality gains lead to less time spent on debugging and bug fixes later in the development cycle, ultimately contributing to a faster delivery of quality software. Enhanced focus. With a partner present, typical workplace distractions, checking social media, answering non-critical emails, are naturally minimized. The shared task at hand naturally encourages focus and keeps both individuals engaged. Different pairing styles. Pair programming isn't a monolithic practice. Different styles can be employed depending on the context, task, and team dynamics. Strong style pairing. Championed by Llewellyn Falco, this style follows a strict rule. For an idea to go from your head into the computer, it must go through someone else's hands. The navigator dictates exactly what the driver should type, never touching the keyboard themselves. This forces the navigator to articulate their thoughts precisely and pushes the driver to truly listen and absorb, maximizing knowledge transfer from the navigator to the driver. Ping-pong pairing. This style is common when using test-driven development, TDD. Developer A writes a failing test, red. Developer B then writes the minimum code necessary to make that test pass, green, and perhaps performs a quick refactor. Then developer B writes the next failing test. Passing the keyboard back to developer A, they ping-pong tests and code back and forth, driving development through a series of small, test-driven iterations. The tourist pair. Less a formal style and more a temporary state. This occurs when one person is significantly more knowledgeable or experienced than the other, and the primary goal is rapid knowledge transfer. The less experienced person acts as the tourist, observing, asking questions, and absorbing, while the more experienced person drives, explaining their rationale as they go. Common myths and misconceptions. The most prevalent myth surrounding pair programming is that it halves productivity. This arises from a simplistic view that equates number of developers directly to lines of code written. However, this ignores the downstream costs of individually written code. More bugs, more rework, longer debugging cycles, less knowledge sharing leading to bus factor risks, and a less cohesive team. When considering the entire software development lifecycle, the investment in pair programming often leads to a net increase in delivered value and overall team efficiency. It's an investment in quality, knowledge, and team resilience that pays dividends. Other myths include: it's only for junior developers. Senior developers benefit from continuous peer review and design discussions. Or it's too exhausting, which can be true if not managed properly, leading to the importance of frequent breaks and switching partners. Practical tips for effective pairing. To make pair programming successful, consider these practical tips. Switch roles frequently. Agree on a regular interval, e.g., every 15 to 30 minutes, or a task-based switch point. This keeps both partners engaged and prevents one from dominating. Take short breaks. The intensity of pairing can be draining. Encourage short breaks every hour or two. Step away from the computer, stretch, grab a drink. Communicate clearly and actively. The driver should verbalize their thoughts. The navigator should ask clarifying questions and articulate their suggestions precisely. Listen intently to your partner. Be respectful and patient. Embrace different working styles. Be open to suggestions that might not be your initial approach. Provide constructive feedback gently. Rotate partners regularly. Don't always pair with the same person. Rotating partners spreads knowledge more widely across the team and keeps interactions fresh. Set up a comfortable environment. Good ergonomic chairs, large monitors, or two distinct monitors, and comfortable keyboards and mice are crucial for sustained pairing. Use visual aids. Whiteboards are excellent for sketching out ideas or explaining complex logic before diving into code. Remote pairing, tools and techniques. The rise of remote work has popularized remote, or distributed, pair programming. While it lacks the physical proximity, modern tools and techniques can make it highly effective. Shared screen software. Tools like Zoom, Google Meet, Microsoft Teams, and dedicated pairing tools like Tuple allow one developer to share their screen, giving the other control of their mouse and keyboard. Collaborative IDEs. Integrated development environments, IDEs, like VS Code Live Share or IntelliJ Code, with me allow multiple developers to work simultaneously within the same editor, seeing each other's cursors and edits in real time. Voice and video communication. A clear, consistent audio and video connection is paramount for effective remote pairing. Explicit communication. Remote pairing often requires even more explicit verbalization from both partners, as subtle nonverbal cues might be missed. Scheduled breaks and time zones. Be mindful of time zones and schedule breaks to prevent fatigue. Pair programming, when embraced and executed, is a powerful tool for building high-quality software, fostering deep collaboration, and accelerating team learning. It transforms software development from a solo endeavor into a truly collaborative art. 5XBS Toolkit. Complementary practices for quality and speed. While pair programming is often seen as the face of extreme programming, it's just one critical piece of a tightly integrated system. XB's true power lies in how its various practices interlock, reinforcing each other to deliver maximum value, quality, and adaptability. Think of XB as a well-engineered machine where each gear, practice, meshes perfectly with others, ensuring smooth operation. This chapter explores these essential complementary practices that form XB's comprehensive toolkit for building robust and agile software. Test-driven development, TDD. The red-green refactor cycle. Test-driven development is arguably the most discipline-heavy and impactful technical practice within XB, next to pair programming. It fundamentally flips the traditional development process on its head. Instead of writing code and then testing it with TDD, you write the test first. The process follows a simple, yet powerful three-step cycle. Red. Write a single, small automated test case for a new piece of functionality. This test should initially fail because the production code it's testing doesn't exist yet. This red light signals that the test is functioning correctly and a piece of functionality is pending. Green. Write just enough production code, the simplest possible code, to make the new test pass. The goal here isn't perfect code or complete functionality, but merely to satisfy the test. This green light shows the functionality is implemented. Refactor. Once the test is green, improve the design of the code. This might involve cleaning up duplicated logic, renaming variables for clarity, or breaking down complex methods into smaller, more manageable ones. The crucial point is that during refactoring, you run all existing tests constantly to ensure you haven't introduced any new bugs or changed the code's external behavior. Benefits of TDD, safety net. The suite of automated tests acts as a robust safety net, giving developers the confidence to refactor and make changes without fear of breaking existing functionality. Better design. TDD forces developers to think about the public interface of their code from the perspective of a consumer, the test, often leading to more modular, testable, and cohesive designs. Reduced defects. Bugs are caught and fixed before the code is even complete, significantly reducing debugging time later in the development cycle. Living documentation. The tests serve as up-to-date, executable documentation of how the code is expected to behave, which IDEs can easily navigate. Continuous integration, CI. Continuous integration is the practice of frequently integrating individual developers' code, changes into a shared main branch of a version control system. Like Git. This isn't just a casual merge. Each integration is immediately verified by an automated build and a suite of tests. The goal is to integrate multiple times a day, not once a week or month. Purpose: detect errors early. By integrating frequently, conflicts and breaking changes are identified and resolved quickly, often within minutes, rather than becoming massive integration hell headaches later in the project. Maintain a releasable state. A successful CI pipeline ensures that the codebase is always in a working, releasable state, making it far easier to deliver small increments of software to customers. Automate tedium. Automated builds and tests remove the manual, error-prone effort of compiling, testing, and sometimes even deploying code. Tools like Jenkins, GitLab CI/CD, GitHub Actions, and CircleCI provide the automated infrastructure for CI. Refactoring. Building on the values of simplicity and courage, refactoring is the disciplined process of improving the internal structure of existing code without changing its external behavior. It's not about adding new features or fixing bugs, though it often helps prevent them. It's about making the code easier to understand, cheaper to modify, and less prone to future defects. This is typically done in small, safe, incremental steps. Why it's crucial for agility: combats technical debt. Software naturally accumulates technical debt, shortcuts, poor design choices, or complexity introduced in the rush to deliver. Refactoring systematically pays down this debt, making the codebase healthier. Enables change. A cleaner, more modular design means that when new requirements emerge, as they always do in Agile projects, the code can be adapted more easily and quickly. Prevents stagnation. Without continuous refactoring, a codebase can become so convoluted that any change becomes risky and time-consuming, bringing development to a grinding halt. Refactoring is made safe and efficient by the presence of a strong suite of automated tests, from TDD and the constant feedback of a CI pipeline. Simple design. XP's philosophy of simple design is encapsulated in the mantra, "Do the simplest thing that could possibly work." This is a powerful counterpoint to the tendency to over-engineer solutions, adding complexity or features, just in case they might be needed later, a common pitfall known as YHNI. You aren't gonna need it. Principle: focus exclusively on meeting current requirements. Resist the urge to build functionality that might be useful in the future. Design code that is as straightforward and understandable as possible. Effect: this approach leads to minimal features delivered quickly, which then allows for rapid feedback from users. The design evolves iteratively, growing in complexity only as real-world needs emerge and are validated. It implies a minimalist approach to architecture, allowing it to emerge rather than be prescribed entirely upfront. Collective code ownership. In an XP team, there are no code specialists or owners of particular modules. Instead, the entire team collectively owns all the code. This means that any developer on the team is empowered to change any part of the codebase to fix a bug, add a feature, or perform refactoring. Benefits: promotes knowledge sharing, eliminates silos of knowledge, and reduces reliance on a single individual bus factor. Increases flexibility. The team isn't blocked waiting for a specific person to become available for a change. Fosters team responsibility. Encourages a sense of shared responsibility for the entire system's health and quality. This practice is enabled by pair programming, which spreads knowledge, TDD, which provides a safety net for changes, and continuous integration, which catches integration problems quickly. Small releases. Instead of lengthy development cycles culminating in a monolithic, big bang, release, XP advocates for delivering working, valuable software in very small, frequent increments. This might mean a new release every 1 to 2 weeks or even daily for web applications. Benefits: rapid feedback. Users get to interact with the software frequently, providing crucial feedback that informs the next development cycle. Reduced risk. Smaller changes are less likely to contain major bugs, and if they do, they are identified and fixed quickly. Market responsiveness. The ability to pivot and adapt to changing market conditions or customer needs is greatly enhanced. Increased trust. Stakeholders see tangible progress frequently, building confidence in the development team. On-site customer. For XP teams, merely gathering requirements from a customer is insufficient. XB proposes having a real, empowered customer representative, or product owner, work directly with the development team on a daily basis. Purpose: immediate clarification. Any questions about requirements or user stories can be answered immediately, eliminating delays and misunderstandings caused by multiple communication layers. Prioritization: the customer can constantly prioritize features and make trade-offs in real time, ensuring the team is always working on the most valuable items. Rapid feedback loop: the customer sees working software as it's built and can provide immediate feedback, ensuring alignment with their vision. The planning game: the planning game is a collaborative approach to planning releases and iterations, short development cycles, usually 1 to 2 weeks. It's a dialogue between the customer and the development team. Customer's role: communicates the story, feature, or requirement and prioritizes what is most valuable. Team's role: estimates the effort required for each story and commits to delivering a subset of stories within the upcoming iteration. This game balances ambition with feasibility, ensures the team is always working on high-value features, and maintains transparent communication about progress and priorities. Coding standards: XB teams typically adopt a set of agreed-upon coding standards. These are rules for how the code should be formatted, named, and structured, e.g., indentation, variable naming conventions, comment styles. Purpose: consistency, ensures that any team member can easily read and understand code written by others, regardless of who authored it. Readability: promotes clear and maintainable code across the entire project. Efficiency: tools can often automate adherence to these standards, freeing developers to focus on functionality. The interlocking nature of XB practices: the true genius of extreme programming lies not in any single practice, but in how these practices are woven together. Pair programming, TDD, and refactoring create a high-quality, flexible codebase. Continuous integration ensures that this quality is maintained even with frequent changes. Simple design and small releases ensure that feedback loops are short and the software remains relevant. The on-site customer and planning game ensure that the team is always building the right software. It's a comprehensive, self-reinforcing system. Each practice serves as a support for the others, leading to a development flow that is highly adaptive, remarkably efficient, and fundamentally focused on delivering exceptional value. 6. From theory to team: adopting extreme programming in practice. Adopting extreme programming is more than just implementing a set of technical practices. It's a journey of cultural and organizational change. While the allure of delivering high-quality software rapidly is strong, successfully transitioning to an XB model requires careful planning, dedication, and a willingness to embrace new ways of working. This chapter outlines the practical considerations for moving from the theory of XB to its daily application within a development team. Prerequisites for XB adoption. Before diving headfirst into XB, it's crucial to assess the readiness of your organization and team. Success often hinges on securing several key prerequisites: management buy-in and support. XB, particularly practices like pair programming and dedicated refactoring time, can initially appear to slow down development or increase costs. Managers must understand the long-term benefits: reduced defects, higher quality, faster adaptability, and improved team knowledge, and be prepared to commit the necessary resources and time for a full cultural shift. Without strong leadership support, skepticism and resistance from within the ranks can quickly derail adoption. Team readiness and openness to change. Not every developer is immediately comfortable with constant collaboration, exposing their work to immediate scrutiny, or adopting a test-first approach. XB requires a team that is genuinely open to learning, willing to experiment, comfortable with giving and receiving direct feedback, and adaptable to new processes. A culture of trust and psychological safety is paramount, where team members feel safe to make mistakes and learn from them collaboratively. Cultural considerations. Organizations with deeply entrenched hierarchical structures, a strong emphasis on individual performance metrics, like lines of code, or a culture of blame may find XB particularly challenging. XP thrives in environments that value collaboration, transparency, continuous improvement, and shared accountability. Starting small, piloting XP on a project. A big bang adoption, trying to implement all XP practices across an entire department simultaneously, is rarely successful. It can be overwhelming, create significant resistance, and lead to failure. A more effective strategy is to start small by piloting XP on a carefully selected project. Choose a non-critical project. Select a project where the stakes are not astronomically high, allowing the team room to experiment and learn without excessive pressure. Select a motivated team. Handpick a team of developers who are enthusiastic about trying new methodologies and are open to the collaborative nature of XP. Their early successes can then serve as a beacon for other teams. Small scope. Start with a project that is manageable in size, allowing the team to quickly gain experience and demonstrate tangible benefits. This pilot approach allows the team to learn and adapt incrementally, building confidence and demonstrating the value of XP to the wider organization. Team composition and roles. While XP emphasizes collective responsibility, some distinct roles are crucial for a successful XP team, though these are often fluid and shared. Programmers. These are the developers actively writing the code, primarily working in pairs. Customer, product owner. This is the empowered representative who works directly with the development team, answering questions, providing immediate clarification on requirements, and prioritizing user stories. They are key to ensuring the team builds the right product. XP coach, optional but recommended. An experienced XP practitioner who guides the team in adopting and adhering to the practices. The coach acts as a mentor, facilitator, and advocate for XP, helping the team overcome challenges, maintain discipline, and understand the why behind their actions. They are not a manager, but a trusted advisor. Tracker, optional. This role, often assumed by a programmer, focuses on collecting metrics, tracking progress, e.g., using burn-down charts, and helping the team understand their velocity and identify areas for improvement. XP traditionally has fewer rigid roles than some other methodologies, encouraging a flatter hierarchy and fostering collective ownership. Setting up the environment. The physical and technical environment should support and encourage XP practices. Physical space for co-located teams, open workspace. An open office layout encourages spontaneous communication and quick information sharing. Pairing stations. Purpose-built workstations with 2 keyboards, 2 mice, and large, dual monitors are ideal for comfortable and efficient pair programming. Whiteboards. Readily available whiteboards are essential for sketching out ideas, diagrams, and discussing solutions during pair programming sessions. Tools and infrastructure. Version control system. A robust system like Git is non-negotiable for managing frequent code integrations and ensuring version history. Automated build server. A reliable continuous integration, CI server, e.g., Jenkins, GitLab CI/CD, GitHub Actions, is fundamental for automating builds and running tests on every code check-in. Testing frameworks. Tools for test-driven development, e.g., JUnit, NUnit, Jest, RSpec, are necessary for rapidly writing and executing automated tests. Refactoring-friendly IDEs. Modern integrated development environments, IDEs with strong refactoring capabilities are invaluable for developers. Communication tools. For remote or hybrid teams, reliable video conferencing, Zoom, Google Meet, and collaborative coding tools, LiveShare, Code with Me, are essential. Investing in the right environment, both physical and technical, creates the conditions necessary for XP practices to flourish. Gradual adoption versus a big bang approach. As mentioned, attempting to implement all XP practices simultaneously is often counterproductive. A more pragmatic approach is gradual adoption, focusing on 1 or 2 key practices first, mastering them, and then layering on others. Start with pair programming and TDD. These 2 practices often provide the most immediate and profound impact on an XP team. Pairing improves communication and knowledge sharing, while TDD provides immediate feedback and builds a safety net for future refactoring. Introduce CI. Once TDD is in place, setting up a solid continuous integration pipeline is a natural next step, leveraging the automated tests to detect integration errors early. Embrace refactoring. As the test suite grows via TDD, the team gains the confidence to aggressively refactor and improve their code quality. Layer in others. Practices like small releases, on-site customer, and the planning game can be introduced as the team matures and becomes comfortable with the core technical practices. This iterative approach to adoption mirrors XB's internal principles, allowing the team to learn, adapt, and refine their process over time. The role of the XB coach or facilitator. The XB coach is often the unsung hero of a successful XB adoption. This individual, or sometimes an external consultant, serves several critical functions. Guidance and mentorship. Helps the team understand the why behind the practices and guides them in their daily application. Discipline and adherence. Ensures the team maintains discipline, especially when under pressure, preventing them from skipping critical practices like TDD or refactoring. Impediment removal. Identifies and helps the team overcome obstacles to effective XB practice. Learning and reflection. Facilitates discussions during retrospectives, helping the team learn from their experiences and continuously improve their process. A strong coach acts as a constant reminder, a source of expertise, and a facilitator for growth, safeguarding the integrity of the XB process amidst the complexities of real-world development. Measuring progress and effectiveness. Measuring success in XB moves beyond simplistic metrics like lines of code or individual productivity. Instead, focus on outcomes that reflect XBS goals. Defect rates. A decrease in the number of bugs found in production is a strong indicator of improved quality, TDD, pairing. Lead time cycle time. How quickly an idea moves from inception to working software in users' hands reflects true velocity, small releases, CI. Customer satisfaction. Regular feedback from the on-site customer and end users confirms that the right software is being built. Team velocity. The consistent delivery of business-valued features reflects the team's predictable progress. Employee morale and retention. Happier, more engaged teams tend to stay, indicative of a healthy and productive environment. Adopting XB is a marathon, not a sprint. It's an ongoing commitment to continuous improvement, deep collaboration, and relentless pursuit of quality. While challenging, the rewards of building truly agile, high-performing teams are well worth the effort. 7. Real-world resonance, case studies, and success stories. The true test of any methodology lies in its application in the real world. Extreme programming, with its unconventional approach to software development, has certainly seen its share of triumphs and tribulations. While a complete, pure XB implementation might be less common today, the impact of its individual practices, particularly pair programming and test-driven development, resonates broadly across the industry. This chapter explores some prominent examples and generalized scenarios, illustrating XB's power and its enduring influence. Anecdote 1. The Chrysler Comprehensive Compensation C3 Project XBS birthplace. The Chrysler Comprehensive Compensation Project, famously known as C3, is where extreme programming was formalized and first applied. In the late 1990s, Daimler-Chrysler faced the daunting task of replacing a critical, monolithic payroll system for its vast workforce. The project was complex, had a challenging deadline, and risked falling into the software crisis trap of cost overruns and delays. Kent Beck was brought in as a consultant by Daimler-Chrysler to help with this troubled project. Faced with the immediate need to deliver value and manage constant change, Beck introduced and refined the set of practices that would become XB. The C3 team lived extreme programming. They engaged in intense pair programming sessions, wrote all their code with test-driven development, continuously integrated their changes, refactored aggressively, and delivered working software every 3 weeks. An on-site customer worked directly with the team, providing rapid feedback and ensuring alignment with business needs. The outcome? The C3 project successfully delivered crucial functionalities of the payroll system under significant pressure. It was not a perfect project. In fact, it was eventually canceled due to external business factors related to the Daimler-Chrysler merger. not because of a failure in the software itself. The team demonstrated that XB could build a complex, business-critical system, adapt to massive changes, and maintain high quality in the face of immense pressure. It proved that extreme collaboration and engineering discipline could yield results. The C3 project became a proof of concept for the Agile movement, showcasing the practical application of ideas that would soon be formalized in the Agile Manifesto. Lesson learned. XB is a powerful methodology for delivering value regularly, adapting to change, and maintaining code quality, even in the most challenging of corporate environments. Its success and ultimate fate highlight that even the best development practices cannot always overcome fundamental business and organizational shifts. Anecdote 2. Pivotal Labs, a bastion of XB discipline. For decades, Pivotal Labs, now part of VMware Tanzu Labs, stood as one of the most prominent and unwavering proponents of extreme programming, particularly its rigorous application of pair programming and test-driven development. As a leading software consultancy, Pivotal Labs helped countless startups and enterprises build and scale their products, often transplanting their pivotal way of working directly into their clients' teams. The Pivotal Way. At Pivotal Labs, all production code was written by pairs. All features were built using TDD. The teams adhered to strict continuous integration, and product owners, or on-site customers, were highly integrated into the daily flow. The co-located, open-plan offices were designed specifically to facilitate pairing and collaborative work. This unwavering commitment to XB practices became their signature. The outcome: Pivotal Labs developed a reputation for extremely high-quality codebases, rapid iteration cycles, and efficient knowledge transfer. Developers who went through the Pivotal Way were known for their disciplined TDD and pairing skills. The company's success was proof that a consistent, company-wide adherence to XB principles could lead to exceptional engineering culture and product delivery. Lesson learned. Disciplined, consistent application of XB practices, especially pair programming and TDD, can build a strong engineering culture, foster high-performing teams, and consistently deliver high-quality, maintainable software. Anecdote 3. A small startup's lean iteration. Consider a hypothetical startup with a tight budget and a burning need to validate their product in the market quickly. They don't have the luxury of a large QA department or lengthy design phases. What might XB offer them? Their approach. This startup embraces pair programming from day one. With a small team, pairing ensures rapid knowledge sharing across the limited codebase, significantly reducing the bus factor, fear of one person leaving and taking critical knowledge with them. They adopt TDD as their primary quality assurance mechanism, as they can't afford a large separate testing team. Continuous integration allows them to release small, functional increments multiple times a day. Their customer might be the founder or a key early adopter, providing immediate feedback. The outcome: the startup rapidly iterates on their product, quickly identifying what resonates with users and what doesn't. Bugs are caught early, meaning fewer costly fixes later. The code remains flexible enough to pivot features without extensive rework. While their initial velocity might seem slower due to pairing, their effective velocity, features delivered, quality, and adaptability, is substantially higher, allowing them to outmaneuver larger, slower competitors. Lesson learned. XB practices, particularly those that promote quality and knowledge sharing, are incredibly valuable in resource-constrained, high-stakes environments like startups, where speed of learning and adaptability are paramount. Anecdote 4. A large enterprise adopting parts of XB. While pure XB implementations are rare in large, established enterprises, the modularity of XBS practices means that many organizations have adopted elements of it with significant success. Their approach: a large, established bank facing challenges with legacy systems, high bug counts, and slow release cycles might choose to implement specific XB practices without undergoing a full organizational overhaul. They might start by introducing test-driven development as a standard for all new development. Concurrently, they invest heavily in setting up robust continuous integration pipelines for automated builds and tests. For particularly complex or critical modules, they might introduce mandatory pair programming, especially for new team members or for senior developers to cross-train on different parts of the system. The outcome: gradually, the bank sees a reduction in defect rates for new features. Their build and deployment processes become more reliable and faster. Knowledge about the critical system spreads, and teams collaborate more effectively, even if they aren't practicing full XP. The cultural shift is slow but positive, building confidence in modern development practices. Lesson learned: individual practices from XP, such as TDD, CI, and pair programming, are highly effective on their own and can be integrated into existing development processes, like Scrum or Kanban, to achieve significant improvements in quality, speed, and knowledge sharing, even in large and traditionally structured organizations. The modularity of XP means it can be adopted incrementally, rather than being a binary, all or nothing proposition. Lessons learned from various scenarios. These case studies, real and illustrative, underscore several key points. Context matters. There's no one-size-fits-all XP implementation. The specific flavor of XP practices and the degree to which they are adopted will depend on the team's size, project type, organizational culture, and existing technical debt. Discipline is key. The power of XP does not come from its practices alone, but from the disciplined, consistent application of those practices. This often requires strong coaching and team commitment. The why reigns supreme. Teams that understand why they are doing XP, e.g., to improve quality, reduce risk, foster collaboration, are far more likely to succeed than those simply following a checklist of rules. XP's values are enduring. While the practices may adapt or be integrated into other frameworks, the core XP values, communication, simplicity, feedback, courage, and respect, remain relevant and crucial for any high-performing software development team. The real-world resonance of XP is not just in its direct implementations, but in how its practices have deeply influenced and improved other Agile methodologies, ensuring its legacy continues to shape the way we build software today. 8. Navigating the naysayers, overcoming common challenges. Adopting extreme programming practices, especially pair programming, often brings with it a unique set of challenges and encounters with skepticism. The shift from traditional individualistic work to a highly collaborative and disciplined environment can generate resistance from various fronts: management, developers, and even the cultural inertia of an organization. Understanding these common pushbacks and having strategies to address them is crucial for a successful XP journey. Resistance to change. The challenge: human nature tends to favor the familiar. Developers might have established comfortable working habits alone, managers might fear a loss of control or initial dips in productivity, and stakeholders might be wary of anything that sounds extreme. This fundamental discomfort with the unknown can manifest as subtle foot-dragging or outright opposition. Overcoming it, education and transparency, clearly explain the why behind XP practices. Frame them not as radical shifts, but as solutions to existing pain points, e.g., too many bugs, slow delivery, knowledge silos. Share success stories and evidence of how these practices lead to better outcomes. Pilot projects. Start with a small, contained pilot project with a willing team. Let their positive experience and demonstrable results serve as the most compelling argument for broader adoption. Involve the team in the how. Don't impose XP top-down. Engage the team in discussions about how to implement various practices, fostering a sense of ownership and reducing the feeling of being dictated to. Address concerns empathetically. Acknowledge anxieties. For instance, reassure individualistic developers that personal time will still be available for learning or non-coding tasks. Perceived slowdown, the halves productivity myth. The challenge: this is perhaps the most persistent and common misconception, especially concerning pair programming. Managers and even some developers might argue that having two people work on one task effectively halves productivity, as measured by lines of code or individual output. Overcoming it: shift measurement focus. Educate stakeholders to measure performance by the outcome, e.g., delivered features, reduced bug counts, speed to market, customer satisfaction, rather than individual output. Emphasize that XB aims for faster delivery of quality software. Highlight hidden costs of solo work. Point out the costs associated with traditional solo development. Longer debugging cycles, higher defect rates, more rework, less effective knowledge transfer, and the bus factor risk. These often far outweigh the perceived inefficiency of pairing. Show total costs. Explain that while the initial commitment of 2 developers on one task might seem like double the cost, the significant reduction in post-development defect fixing, quicker integration, and improved maintainability often results in a lower TCO, total cost of ownership, over the project's lifespan. Emphasize quality. Clearly articulate that pair programming is not just about writing code, but about constant quality assurance, shared learning, and immediate design review. Personality clashes in pairing. The challenge: despite the benefits, not everyone is immediately comfortable spending their entire day in close collaboration, and not all personalities mesh perfectly. Different working styles, e.g., highly analytical versus intuitive, fast-paced versus meticulous, talkative vs quiet, can lead to friction or discomfort. Overcoming it: rotating partners. Encourage frequent rotation of pairing partners. This not only spreads knowledge more widely, but also ensures that no one is stuck with an incompatible partner for too long. Planned breaks and unpaired time. Implement regular breaks during pairing sessions. Also, ensure there is designated, unpaired time for individual tasks like email, research, or personal development. This helps manage the intensity and mental fatigue. Communication skills training. Provide training on effective communication, active listening, and conflict resolution. Role-playing scenarios can help teams practice navigating difficult conversations respectfully. Emphasize mutual respect. Reinforce the XB value of mutual respect. Encourage empathy and understanding of different working styles, fostering a culture where feedback is constructive and not personal. Coach intervention. An XB coach can help mediate conflicts or provide guidance on effective pairing techniques if issues arise. Burnout and fatigue. The challenge: the constant mental engagement required by practices like pair programming and TDD can be draining. Developers might experience burnout if not managed properly. Overcoming it: mandatory breaks. Enforce short, frequent breaks during pairing sessions. Encourage developers to get up, stretch, and step away from the screen. Sustainable pace. Advocate for a sustainable work pace. XB is designed for continuous delivery, not frantic sprints followed by burnout. Overtime should be the exception, not the norm. Diverse tasks. Ensure developers have a mix of tasks, some of which might be individual, e.g., research, attending a meeting, self-study, to provide a mental break from constant pairing. Encourage self-care. Promote a culture that values work-life balance and encourages physical activity and sufficient rest outside of work hours. Inexperienced teams and skill gaps. The challenge: teams new to Agile or XB might lack experience with specific practices like TDD, refactoring, or simply the knack for effective pair programming. This can lead to frustration and a perception that XB is too difficult. Overcoming it: strong coaching. An experienced XB coach is invaluable for guiding less experienced teams, providing hands-on training, and patiently explaining the why behind the practices. Peer mentoring. Encourage knowledgeable team members to mentor and guide others. The pairing process itself is a powerful form of continuous learning. Structured training. Invest in formal training sessions for TDD, refactoring techniques, and effective communication skills. Start simple. Begin with simpler projects or tasks that allow the team to practice the core XB concepts without excessive complexity. Celebrate small victories to build confidence. Tooling and infrastructure investment. The challenge: implementing practices like continuous integration, test-driven development, and robust automated testing requires significant upfront investment in tools, infrastructure, and expertise. Setting up and maintaining build pipelines, test environments, and collaborative development tools can be daunting. Overcoming it: prioritize automation. Recognize that the upfront investment in automation pays off significantly in terms of long-term efficiency, quality, and reduced manual effort. Expert assistance. If internal expertise is lacking, engage external consultants or specialists to help set up the necessary infrastructure. Incremental tooling. Don't try to automate everything at once. Prioritize the most impactful automation, like basic CI builds and unit testing, and then expand gradually. Treat tools as products. View your build and test infrastructure as a product that needs continuous development and maintenance, just like your core application. Maintaining discipline. The challenge: when deadlines loom or pressure mounts, it's easy for teams to slip back into old, less disciplined habits. Skipping tests, neglecting refactoring, or developers working in isolation. Maintaining the discipline required by XP can be difficult, especially initially. Overcoming it. The XP coach's role. A dedicated XP coach is crucial for consistently reinforcing the practices, reminding the team of the why, and holding them accountable. Team agreements. Create explicit team agreements about how practices will be followed. Peer pressure, positive, can be a powerful motivator. Regular retrospectives. Use Agile retrospectives to frequently reflect on how well the team is adhering to its agreed-upon practices and identify ways to continuously improve. Celebrate successes. Acknowledge and celebrate when the team successfully adheres to practices, especially when it leads to tangible benefits like fewer bugs or faster delivery. Navigating these challenges requires resilience, open communication, and a deep understanding of the long-term benefits XP provides. By proactively addressing skepticism and planning for common pitfalls, teams can set themselves up for a more successful and less turbulent adoption journey. 9. Beyond the extreme. XP's enduring legacy and evolution. Extreme programming, as a distinct methodology or framework, no longer commands the same spotlight it did in the early 2000s. Its extreme label, once a powerful differentiator, now feels somewhat dated in an age where agility and collaboration are widely accepted norms. Yet, to conclude that XP somehow failed would be a profound misreading of its impact. Instead, XP's enduring legacy is a testament to its success. Its core practices have been so widely adopted, integrated, and, one might even say, absorbed into the mainstream of software development that they are now often taken for granted. XP didn't disappear. It dissolved into the very fabric of modern software engineering. How XP has influenced other Agile frameworks. XP was one of the early pioneers of Agile, evolving in parallel with, and sometimes influencing, other approaches. Scrum, with its focus on project management through iterations, sprints, roles, Scrum Master, Product Owner, and ceremonies, daily stand-ups, sprint reviews, retrospectives, provides a much looser framework for how software development actually happens. It intentionally leaves the technical implementation details to the development team. This is where XP's engineering practices have filled a critical gap. Many, if not most, high-performing Scrum teams today implicitly or explicitly adopt core XP practices like test-driven development, continuous integration, refactoring, and pair programming. These XP practices inside Scrum help teams achieve the high quality and rapid adaptability necessary to truly deliver value within their sprints. Without XP's technical discipline, a Scrum team risks building up technical debt and delivering low-quality software, even if they meet their sprint commitments. Kanban, focused on optimizing flow, limiting work in progress, and continuous delivery, Kanban systems benefit immensely from the technical rigor offered by XP. Practices like TDD and CI ensure that work items are developed with high quality and do not get stuck in the pipeline due to defects, thus maintaining a smooth and efficient flow of value. The emphasis on continuous improvement and reflection in Kanban aligns naturally with XP's philosophy of consistent self-assessment and adaptation. The emergence of Agile software craftsmanship. XP's strong emphasis on technical excellence and coding discipline directly fueled the emergence of the Agile software craftsmanship movement. This movement, gaining prominence in the late 2000s, called for professionalism and mastery in software development, moving beyond simply delivering features to delivering well-crafted, maintainable, and robust solutions. Key tenets of software craftsmanship, codified in principles and practices, are direct descendants of XP, TDD, and refactoring. central to the craftsman's toolkit, ensuring code quality and evolvability. Clean code. Principles for writing readable, understandable, and manageable code, heavily influenced by XPS simplicity and coding standards. Pair programming. A core element of collaborative learning and knowledge transfer among craftsmen. Continuous learning. The commitment to continuously improve one's skills, a reflection of XPS improvement principle. The craftsman perspective provided a much-needed focus on the engineering side of Agile, ensuring that the push for speed and flexibility did not come at the expense of technical quality. DevOps movement, its strong ties to XP practices. The rise of the DevOps movement, which aims to bridge the gap between development and operations teams, draws heavily on XP's foundational technical practices. DevOps emphasizes automation, collaboration, and continuous delivery pipelines, all of which find their roots in XP. Continuous integration, CI, a cornerstone of DevOps, allowing frequent code merges and automated testing, directly inherited from XP. Continuous delivery deployment, CD, the ability to release software automatically and reliably to production, built upon the foundation laid by XPS CI and small releases practices. Automated testing. The pervasive use of automated tests, a direct legacy of TDD, is critical for DevOps to ensure the stability and reliability of rapid deployments. Shared responsibility. The collaborative spirit of DevOps, breaking down traditional silos between dev and ops, mirrors XP's collective code ownership and emphasis on team accountability. In essence, XP's rigorous engineering practices laid the technical groundwork that made the ambitious goals of DevOps achievable. The enduring relevance of XP's core values and principles. While the specific structure of an XP team might be less common, the underlying values and principles of XP remain incredibly relevant, perhaps even more so, in today's complex development landscape. Communication. In an increasingly distributed and remote world, effective communication is paramount. XP's emphasis on direct, frequent dialogue, even if via video call, still underpins effective teamwork. Simplicity. With systems growing in complexity, striving for the simplest possible solution and avoiding unnecessary abstraction is more critical than ever. Feedback. The need for rapid feedback loops from users, tests, and team members is universal for any adaptive process. Courage, the courage to refactor, to admit mistakes, to challenge assumptions, and to embrace change is a timeless virtue for any successful team. Respect. Fostering a respectful, psychologically safe environment where diverse perspectives are valued is key to unlocking creativity and collaboration. These values, along with principles like baby steps, quality, and reflection, transcend any specific methodology. They are the bedrock of effective modern software development. Hybrid methodologies. XPS legacy in action. Today, it's rare to find a team that strictly adheres to pure XP. Instead, the common approach is to create a hybrid methodology, thoughtfully selecting beneficial practices from various Agile frameworks and adapting them to the specific context of the project and organization. A highly prevalent example is Scrum with XP practices, where the management framework of Scrum provides structure, and the engineering discipline of XP, TDD, CI, pair programming ensures high-quality code and continuous delivery. XP's brilliant contribution was to integrate sound engineering principles directly into the daily development workflow, rather than treating them as separate, detached phases. It shifted the mindset from testing happens after coding to testing drives coding, and from isolated coding leading to code reviews to integrated, real-time code collaboration. Where XP stands today is not as a separate entity, but as a foundational contribution to modern software development. Its ideas are so widely adopted that they don't always carry the XP label anymore, but their profound influence is undeniable. The software industry is now much more agile, adaptable, and focused on quality partly because of extreme programming. It taught us to lean into the extreme demands of continuous feedback and collaboration, and in doing so, transformed the very nature of building software. 10. The collaborative frontier. The future of software development. We began this journey by challenging the romanticized image of the solitary coder, arguing that modern software development is fundamentally a collaborative endeavor. As we conclude, this truth rings louder than ever. The lessons embedded within extreme programming and the power of pair programming offer a compelling vision for the future. A future where advanced technology is built not by isolated brilliance, but by the combined intellect, shared passion, and persistent collaboration of highly effective teams. The complexities of today's digital landscape demand nothing less. Software is no longer a peripheral business function. It is often the core product, the primary service, or the critical differentiator for most organizations. As such, the stakes are incredibly high. The persistent need for quality, adaptability, and continuous learning in software development is not merely a trend. It is the fundamental reality of our profession. XP's values and practices, refined over decades, directly address these enduring requirements, providing concrete ways to deliver robust, high-value systems while remaining flexible in the face of relentless change. Consider the ongoing advancements in artificial intelligence and automation. Tools powered by AI promise to revolutionize how developers work, assisting with code completion, identifying bugs, and even generating code snippets. Automated tools already manage build pipelines, deploy applications, and perform routine tests. Yet, even as more tasks become automated, the human element of software development, understanding complex requirements, designing innovative solutions, resolving nuanced logical challenges, and ensuring the human-centric aspects of user experience will remain paramount. The principles of collaboration, continuous feedback, simple design, and effective communication, so central to XP, will not just endure, but will become even more crucial as human teams learn to effectively pair with their AI counterparts and leverage advanced automation. The ability to articulate problems, critique solutions, and coordinate efforts across human and artificial intelligences will define the next generation of software teams. Successful teams in this evolving frontier will invariably be characterized by their commitment to continuous learning and adaptation. The rapid pace of technological change means that yesterday's cutting-edge tool is today's legacy, and yesterday's best practice might be tomorrow's bottleneck. XP, at its heart, is a methodology built on the premise of continuous improvement and reflection. It encourages experimentation, learning from failure, and evolving processes based on real-world feedback. Teams that embody these traits, constantly questioning, learning, and refining their approach, will be the ones that thrive. Summary of key takeaways. Extreme collaboration is productive collaboration. Far from being an inefficient luxury, the intensive collaboration exemplified by pair programming and other XP practices leads to higher quality, faster delivery, better knowledge sharing, and stronger, more resilient teams. It's an investment that yields significant returns. Quality is built in, not bolted on. Practices like test-driven development and refactoring embed quality directly into the development process, reducing defects, accelerating debugging, and ensuring the codebase remains flexible and maintainable. Adaptability is key. XP's emphasis on small releases, frequent customer feedback, and simple design ensures that teams can gracefully respond to changing requirements and market conditions, delivering relevant software sooner. Values drive practices. The power of XP isn't just in its technical practices, but in the underlying values of communication, simplicity, feedback, courage, and respect. These values cultivate the optimal environment for high-performing teams to flourish. XP's enduring legacy. While seldom adopted as a complete framework anymore, XP's practices have been widely integrated into other Agile methodologies, fundamentally shaping how modern software is built and laying the groundwork for movements like DevOps and Agile software craftsmanship. The journey to effective collaboration is an iterative one. It requires courage, the courage to step outside comfort zones, to embrace transparency, and to trust in the collective intelligence of the team. It calls for discipline, the discipline to practice TDD consistently, to refactor continuously, and to communicate openly, even when it's uncomfortable. But the rewards are immense. Not just better software, but happier, more skilled, and more effective teams who are truly masters of their craft. We encourage you to experiment. Try pair programming on a small task. Implement test-driven development for a new feature. Advocate for more communication and transparency within your team. Begin with baby steps, reflect on the results, and adapt. The collaborative frontier awaits, and the principles of extreme programming offer a powerful compass to navigate its ever-evolving landscape. Embrace extreme collaboration, and together, we can build the future of software. Further reading and resources, Beck, Kent, Extreme Programming Explained, Embrace Change, Addison Wesley Professional. The seminal work on XB, available in first and second editions, providing the foundational concepts. Beck, Kent, Test-Driven Development, by example, Addison Wesley Professional. A Practical Guide to TDD by its originator. Fowler Martin, Refactoring, Improving the Design of Existing Code. Addison Wesley Professional. A Comprehensive Guide to the Refactoring Process. Martin, Robert C. Clean Code, A Handbook of Agile Software Craftsmanship. Prentice Hall. Emphasizes coding discipline and principles that align with XB. Agile Alliance, agilealliance.org, a nonprofit organization promoting the Agile Manifesto's values and principles, provides articles, resources, and organizes conferences. martinfowler.com. martinfowler.com. Martin Fowler's extensive website, featuring numerous detailed articles and essays on XB, refactoring, continuous integration, and other Agile topics. Various online communities and blogs. Resources like Stack Overflow, Medium, and numerous developer blogs often feature discussions and practical advice on pair programming, TDD, and Agile practices.